Hello, congratulations, you have made it to the end of today's lesson. We are on example number 7 here, which is dividing complex numbers. Okay, that's the last operation we want to do. We want to know how to divide by a complex number. I'm going to step aside from this example here for a moment and talk about just some general concepts. So I want to talk about conventions. Conventions being the way that we conventionally do math and conventionally feel satisfied where we have ended a math problem or ended the way that we're going to write a math expression. So for example, if we were doing math and we got to a step like this, 1 over 1/2, conventionally, we would not stop here. Now, there's nothing wrong with saying 1 divided by 1/2. That is perfectly fine to do. However, the step we would take is we would try to change this so that we did not have a fraction on the bottom. Same thing with this one. If we ended with a square root, some kind of radical on the bottom, we would conventionally want to get rid of that. And now, while we're dealing with complex numbers, the combination of real numbers and imaginary numbers, if we end with a complex number on the bottom, we want to get rid of that. We don't want to leave it like this. Now, once again, none of these three things are improper ways of writing something. It's just that conventionally we don't end there. So what do we do on the first example? Well, to get rid of this fraction on the bottom, we would have to multiply by 2 over 2, right? The only way that we can really change a expression without changing the value is by multiplying by 1. So we've got to come up with different clever ways to multiply by 1. In this case, 1/2 times 2 gives us 1 on the bottom. 1 times 2 is 2 on the top. Everything looks good. So we've taken our original expression, changed it to something that conventionally is where we want to end. For a radical on the bottom, we'd want to multiply by that radical over itself. So once again, just multiplying by 1, but in this case, square root of 2 times square root of 2 makes the square root go away. We get square root of 2 on top, and this would be conventionally how you would rearrange this expression to a more conventional way of writing it. Okay, finally, if we have a complex number on the bottom, what we're going to multiply by is its complex conjugate. Basically, just change this plus sign to a minus sign. Now, if that's on top and bottom, we're once again just multiplying by 1. Let's take a look at how that turns out. Well, if you have 2 plus I and 2 minus I, the 2's make a 4, 2 and the negative I make a negative 2I, the 2 and the positive I make a positive 2I, and the I and negative I make a negative I squared. 2I and negative 2I cancel out, so we're left with 4 minus I squared, which I have down here. I squared, if we know our definition here of what I squared is negative 1. So 4 minus negative 1 would be 5, right? So this would be how we would rearrange that so that we have a conventionally better way of writing it down. We moved our complex number from the bottom of the fraction to the top, and we are now satisfied with that. All right, so that is what we are going to try to do here. So looking at this example, we have 5i over 3 plus 2i. So to get rid of this complex number on the bottom, we are going to multiply the fraction by its complex conjugate over itself. Okay, when we do that, 3 plus 2i, 3 plus 2i times 3 minus 2i, we get 9 in this corner. We get 6i and negative 6i, which will cancel out, and a negative 4i squared down here. I squared being negative 1. This altogether is negative 4 times negative 1, or positive 4. Positive 4 and 9 makes 13. You'll see that happening on the document right here. Okay, we get 9 minus 4i squared on the bottom. 9 minus 4 times negative 1, 13, what we just went through. Now on the top, we have 5i times 3 minus 2i. Well, that's just a distribution. So 5i times 3 is 15i. 5i times negative 2i is negative 10i squared. That I squared can become a negative 1. So that 10 times the negative 1, the minus 10 times negative 1 becomes positive 10. And we are left with our final answer. The last step that they'll have you take is they'll take this complex number divided by 13, and they'll just break it up into two parts. Instead of saying 15i plus 10 over 13, they'll say it's 10 over 13 and 15i over 13. And there you go. That would be your final answer. And if you look here, you can see that our solution of dividing by this complex number ended up once again being a complex number. We have a real part here, some fraction, 10 over 13, and an imaginary part here. Okay, as long as you have followed along well enough with all that, you have made it through this lesson on imaginary and complex numbers. Pat yourself on the back. It is a difficult and kind of groundbreaking topic to work on. Glad you made it through. Thanks.